Hey guys, I wanted to go over just some basic function shapes with you so that way you have an understanding of how the problems or what your graphs will look like whenever you're dealing with these problems. So just basic shapes. The very first one should be simple to understand and know. A linear graph, a straight line. The domain and range of a linear graph is all real numbers. Quadratic, that is where you have that U-shaped, x squared. So this one here, this is in basic form, and I'll just write it like this. This is something like y equals x, and then you can have plus 2. So what I'll do for the number, I'm going to write the plus c, okay? And this one here is something like y equals x squared plus, I could have cx plus c, all right? And that gives you the basic U shape. Your domain for quadratics is all real numbers. Your y varies. Your y varies. It's based off of where it's actually located. If it opens up or if it opens down. Your cubic, it has this basic shape, and we're looking at something like this: y equals x cubed, and we could have x squared and x. The domain is all real numbers. Your range will end up being all real numbers. Now, earlier in the videos, I told you your domain for all polynomials, so for all polynomial functions, your domain is all real numbers. And you write it like this: x such that x equals, and then this is the symbol for real numbers, all real numbers. This is set builder notation. This is interval notation. I do not think your book or any of your problems use set builder. This is just interval notation, so that's how we'll do it. In case you're familiar with that, that helps you to be able to visualize and take it to what's written there. That is for all polynomials. So remember, what makes it a polynomial is whenever your exponent is a whole number. Well, what we have with rational and radical is where we ended up with uh, exponents that were negative for your rational, and uh, for your radical, your square roots, you had exponents that were fractions. Fractions. So this is something simple like this. Okay, x over x minus 1. And what you have here is you have more or less two graphs, but there's going to be a point that's not included if the denominator goes to 0. So there are many different types. This is just a basic graph of it. What they call this a hyperbola. The domain is all real numbers, in this case except for 0. 0 can't be included, just in the graph that I drew. And then same for the range. Range is all real numbers except for y equals 0. This is how you write the domain in set builder, and then this is how you write the domain in interval notations. And for your radical, this is your basic shape of your radical. Again, all of these graphs can be moved around the coordinate plane based off of the numbers that are with your basic graph. Absolute value graph, the domain is all real numbers. So this right here, whenever you say the domain is all real numbers, here, 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 and here, what you're looking at, these are what your polynomials are. These are not considered polynomials, as we covered in prior sections. So there's your basic graphs. It helped give you an understanding and an idea of how they look. And then what I have also is just some basic things for you to be able to look at and think of. Even powered functions all have the same basic shape and end behavior. They open up like this, or they can open down like this, depending upon the sign of the leading term's coefficient. But they'll have that basic shape. Again, what's going on in the middle may be a little different. Okay, what's going on in the middle may be a little different. Odd powered functions all have the same basic shape and endpoints. Something like this. Again, in the middle can be different. All odd powers in a function. So if there's only odd powered variables in the function, there is symmetry about the origin. So if I have the origin here, there's going to be some kind of symmetry about that origin. If I have all even powers in a function, you'll have symmetry about the y-axis. Symmetry means same on both sides is the easiest way to put it. Okay. Symmetry about the origin, meaning I could take this portion up here and whenever I flip it, it looks just like this one. And symmetry about the y-axis, that means on the left side of the y-axis is the same as on the right side of the y-axis. And that is just a basic overview of characteristics of graphs that you can take away to be able to help you whenever you do your homework. As soon as you look at the structure of the quadratic of the polynomial function, you should be able to have an idea, okay, this is what it looks like. Please continue to watch the publisher's videos, structure, and critically think about your homework, and good luck on your homework.